Hi, welcome to another video on my channel. If you are new to the channel, please do the right thing and subscribe so that you can be kept up to date with future videos and content, right? And if you are a returning viewer and you have not yet subscribed, just do the right thing and subscribe to the channel so that you can know when I upload new video, right? Because it's all about building your math IQ. And please share the video to families and friends as well, and also share the channel link to everyone that you know, especially persons who are doing math at the moment, right? So that everybody can get the right information. Alright, so for this video we are going to look at index numbers. We're going to move a different level in index numbers. We're going to look at how to multiply index numbers with uncommon bases. But before we move into that, we're going to look at a few objectives first, right? So we're going to look at 1 and 2 before we move into multiplying index numbers with uncommon bases. Number 1 is where we're going to explore index numbers with common bases, and 2, explore index numbers with uncommon bases, right? So I'm going to explore those two before I move into what this video is really about, which is objective 3, where we will multiply index numbers with uncommon bases. Alright, so firstly we're going to look at index numbers with common bases, right? And a set of index numbers with common bases are written, well, this should be is, right? Right, a set of index numbers with common bases is written in the form below. And since we're on common bases, I wanted to pay close attention to these 4 terms right here, right? And in previous videos I outlined to you that index numbers are written in this form with a base raised to a number, right? And remember, the base cannot be 0. So on the matter of common bases now, if you notice, 4 terms are here, but if you should notice, all of them have a base of a, right? Everything has a base of a. Everything leads to one base, which is a, right? So these are basically terms with a common base. And numerically, if I have 2 square, 2 cube, 2 to the 4th, 2 to the 12th, and 2 to any number, 2 to the n. N as in, n can be any number. So I can stop there. If you notice, all of these numbers, they all have a common base of 2, right? So all of these are index numbers with common base, right? Everyone has a 2, right? So I hope that clears up any misconception that you had in terms of bases with in terms of uncommon base or common base. Alright, let's move to the next stage now, where we're looking at index numbers with uncommon bases, right? And let me change this one as well. A set of index numbers with uncommon bases is written in the form below. Forms, right? Yes. So we're looking at uncommon bases, and if something is not common, then they are different, right? And if you notice all these terms right here, 1, 2, 3, 4, This one has A as the base, this one has B, this one has C, this one has D. They are different, so they are not common. So these are basically terms with uncommon bases, right? So if I should give you some numerical examples, you could see things like 2 square, 3 to the 4th, right? 5 to the 3rd power, or 5 cube, and 6 to the 1st power, and even this 9 to the n power. N can be anything. So if you notice, for the bases are different. So these are uncommon bases, right? So I hope you see the difference now between common and uncommon bases when it comes down to index numbers. All right, let me move into this part now. Multiplying index numbers with uncommon bases. So if this asks you to find the numerical value of each of the following, that means you're going to do the expansion and then you also write your numerical answer, the final answer. So in this case, if we should look at this first part, 2 to the 3rd power, or 2 cube, would be 2 times 2 times 2, right? So I write 2 3 times because we have a base of 2 and a power of 3. Multiplication remains the same, and now have 3 squared, which would be 3 times 3, right? This would equal to, all of this would give you 8 multiplied by 9, which would give us 72. Right, so all we did was expand each term, then we multiply them. Let me use a different color for this one. This would now give us 1 to the 4th. It's a 1 times 1 times 1 times 1. Multiplication remains the same. Multiply by 5 square, 5 times 5. And if you don't know how to expand index numbers, please move to my video that teaches you how to do so, and I will leave a link in the description for you to find it. So 1 times 1 times 1 times 1 will give you 1, and then 5 times 5 is 25. So multiplication sign remains 20. You get, sorry, and we have 25 here. So 1 times 25 is equal to 25. Alright, so moving on now. 6 squared is basically 6 times 6. Multiplication remains. 4 cube is 4 times 4 times 4, which would give us, this is actually 36 times, so the 6 times 6 gives 36, times 4 times 4 times 4 would give us 64, and 36 times 64 gives us 2304. Right, so all we have to do is to expand each of them individually, each term individually. Alright, moving on to the next one now. So 10 to the 4th is 10 times 10 times 10 times 10. We write 10 4 times because I have a 4 at the top. Multiply, which is this multiplication sign, 3 to the 3rd. 3 times 3 times 3. Right? This would give us, let me see, 1, 2, 3, 4. That's 4 zeros, so that's basically 10,000. 10,000 multiplied by 27. 3 times 3 times 3 gives 27, which would give us 270,000. right? So it's clear that all we do is expand each term fully, and then we do the multiplication. And for the last one now, that says 23 square times 2 to the 4th. As I said, expand each term or each index number individually. So 23 square would give us 23 times 23. Multiplication remains the same. Multiply by 2 to the 4th. So 2 times 2 times 2 times 2. This will give us 23 times 23 would give us 529 multiplied by 16. So this 16 came as a result of multiplying 2 times 2 times 2 times 2. So 529 times 16 would give us 8,464. 464. Right? So that's basically how we multiply index numbers with uncommon bases. So we just expand each index number and then we just carry out the multiplication. So it's similar to what I taught in the original index video. So for this we have 2 cube times 3 square. Remember now, the only thing I did was to just expand this, right, and expand this, and just go back to the original video and exponent and you'll see how we deal with one term. All we did was to put two index numbers together and multiply them. So it's not anything that difficult. Rewind the video, replay it, fast forward it, and do anything you want to do with it so you can understand. So if this video has created any form of value to you in terms of helping you to understand this topic better, I would appreciate it if you leave a comment in the comment section stating how it has helped you and other videos that you want to see be created. And remember, please subscribe to the channel, share the video, and also put forward the good vibes for the overall channel. Have a wonderful rest of the day or night. Thank you.